In this video, we're going to quickly discuss the normal model and what it tells us. So what the normal model is certain data follows this types of distribution where the majority of the data is in the middle, that's the peak. And as you get closer to the edges, there's not as many people out there, like heights, for example. Most adults are in some normal range of heights. And when you get out here on the extremes, they might have some really short and really tall people, but not as many. And that's why this curve comes down, showing me there's not as many people out here on the edges. So when you have a normal model, we always start by putting the mean in the center, and we let each one of these tick marks represent one standard deviation. To the right would be one standard deviation greater than the mean. To the left would be one standard deviation, etc., lower than the mean. That's why they're negative. All normal models follow the same percentages between these standard deviations. And so you need to memorize these: 68, 95, 99. What that 68 means is it means from within -1 to 1 standard deviation is 68% of the data. So this total distance here with -1 to 1 is 68. With the mean in the middle, if we cut that in half, you get 34 and 34. The 95 is within -2 to 2. So from here all the way to here is 95% of the data. Well, if 68 was in the middle, if I subtract 95 minus 68, then I get what would be in these two pieces. And if I cut that in half, I get what is in each one. And that turns out to be 13.5. And then the 99 is from -3 to 3. That's from here to here. That's a total of 99. If you subtract out all this middle section, split the difference, you get 2% and 2%. And then there's 1% left over, and that gets split out into 0.5%, 0.5% and 0.5%. So now, if I tell you SAT scores follow a normal model with a mean of, let's say, I'm just making these numbers up here. Let's say the average SAT score on a single subject test is about 400 with a standard deviation of 150. So now what I can do when I'm told that is I put the mean, that's the 400, right in the middle, and each one of these marks represents 150 points. So this would be 550. So I added 150 to 550. If I add another 150, I get 700. If I add another, I get 850. And if I go the other way, I'm going to subtract off 250, subtract off another 150, you get 100, and subtract off another 150, and you're going to get -50. All right, and sometimes they ask questions like, what is the approximate range? Range is the total distance from the smallest to the largest, and these numbers don't need to be literally the largest and the smallest, but they're pretty close. There's only 1% of data potentially more extreme, which is a really low number. So my range for this one would go from 850, we subtract the smallest number, so it would be approximately 900 points. This total distance, that would be the range. And then they ask questions like, what percent of the data is between, and then they give you two scores. So like, let's say I say between 250 and 700. What percent of the data is between 250 and 700? So if I find those two values on my curve, they're asking me what percent is this whole section. And as long as you know your percentages, your 68, 95, 99, you can break them down. I'm just adding up now 34 plus 34 plus 13.5. That's 68. And that's going to be 81.5. And that is my final answer. And you could then break it down between other ones, like between 100 and 200 would be, and 250 would be 13 and a half, or between 100 and 400 would be these two added together, and so forth.